Hello and welcome to this tutorial where I'm going to give you a quick overview of how to use our Python API to control our robot remotely via a network. So to start off, go to our GitHub page and have a look for a repo called Inovo_Roslib. It's the one with the Python note there. So we click on that and you'll see a set of files, the SequenceClient, simple motion, simple trajectory, and some requirements and readmes. Down here is a bit of documentation to explain how to use it and get started. So I'm going to take a copy of the URL and I'm going to use a simple tool. I'm going to use tortoise git to clone this, but obviously you can do it from the command line. There's no credentials required because this is a public repo. So I'm just going to pull the files and there we go. Now I'm going to take that, I'm going to open it in Visual Studio Code. Obviously, again, no restriction on editors, but you do need Python installed and you'll need pip to manage some of the dependencies. So here you go, here are the files. I'm going to open up a terminal as well. And one of the things that you will need to do is install the prerequisites. Now, you may well already have this if you've been doing some work with ROS, but you'll need to go pip3 install -r requirements.txt, and this will install the Python ROS bridge. So run that. I've already got it installed, so it's saying that it's already satisfied, but it's the same process, just slightly slower if it needs to be installed. So having done that, we can build up an example file. So what I'm going to do is go new file and demo.py, and then I've got my file here, and I'm going to go back and refer to the documentation README on the GitHub page. So we're going to start off by importing the roslib.py and also the SequenceClient. So I'll just put those two lines at the top. We're now going to create an instance of the client, and this bit needs a bit more attention because you're going to need to set the IP or host name of your client. The client is the robot. So in this example, I've got a robot on my network and this is its IP address. So it's the IP address you put into the browser to open up the user interface. So I'm going to copy that. I don't need the HTTP or HTTPS. I just need the IP address or host name on its own. So that goes in there, and I'll take out the HTTP and any slashes on the end. Now the port is 9090, you don't need to change anything there, so that's now done. And then next, using that instance, we're going to call the run function. Finally, at the end of your application, you're going to need to close down this connection, and so I can again reference the GitLab page to see the wording for that. So it's client.terminate, and that goes at the end of your file down there. So then what we're going to do is we're going to build our application in the middle. And one of the first things we can do is just a quick check to see if the connections worked. So having called the run function, we then can just use the isConnected function to check that. So I've now got this, and if I run this and watch what happens in the terminal, you should see it run and it says is ROS connected, and then it's returned true, which is a great start. So all we've done is opened the connection, checked it's working, and closed it again. But this is the interesting bit. So now what we're going to do is we're going to create an instance of the SequenceClient, and I'll just paste that in again. So it's SequenceClient. We're giving it the reference to the client instance that we've created and the path. So we're now going to have an instance called SC, which is short for SequenceClient. Now, the SequenceClient, we can use any of the functions that are described here. So there's functions to get the status of the sequencer. Is it running? Is it paused? Is it idle? We can call start and stop and pause and step to do the same things as these buttons at the top here if you're working directly in the user interface. We can even call specific functions. So in this example, we've got a couple of functions already defined. We've got the pick and place. So what I'm going to do is I'm just going to put it directly under start and run it there. What you can see is that is just doing that part of the function there, part of the motion, and then Second bit, we'll place it over there. So this should, when I run it, go to the pick point, come up, go across to the place point, go down, and that's it. Now, I can just use the start function in Python to call that directly. So what I'm going to do is make this window a bit smaller, come over here, and I'm going to just, using my SequenceClient, I'm going to call start and the brackets afterwards. So what this will do is I'm going to click play here to run my Python, and then I'm going to tab over to the window for the user interface just to see what's actually going on. So ready, and click there, jump across. You can still see the terminal in the background there, and you can see that it started the sequence. I didn't click on the run. The run has basically been done by Python. What you might have noticed is that the Python actually finished before this finished, and that's because start isn't a blocking function. Start is just a trigger. So if I go print done there and run it again, and see it's already said done, but the sequence is still running in the background. Now, there's a way around this is to use one of the functions to get the status. So I can go get the status, and this will return an integer which equates to whether it's in idle or running or paused. A friendly wrapper function around this is actually called wait until idle. And if I add that and run it again, what we'll see is that it's connected, it's running it, but it hasn't printed done yet until the sequence finishes. There you go, and done. So this is a nicer way to synchronize it if I've got a whole step of things I want to do. But of course, you might not want to run the whole sequence. You might want to just use blocks of functionality. And one nice way to do that is to put blocks of functionality in functions and then call them specifically. So I've got a function here called doPlace and another one called doPick. Now I can then use the Python to call those specifically. So rather than calling start, I can go call function, and then I can give it the name of that function, doPick. So now what's going to happen is it will do the pick part of my sequence. So I'm just going to click play again. It's running that. It's doing the pick, and then it stops. And similarly, I could do the same with place. I could even do it several times. So I could do a pick, do a place, and then do another pick. So if I run that again, see it's going to do the pick. It's going to now do the place, and then it's going to go back again and do the pick. And then obviously, because this is your own Python application running on any machine you want, that can be linking to external databases, to other equipment, to your own user interface, and gives you a lot of flexibility to use pockets of functionality in the robot interacting with other systems. So thank you for listening to this tutorial. Please check out some of our videos. And if you have any specific questions, feel free to email support@inovorobotics.com.